Hello everyone, welcome to part 1 of a series of tutorials where we'll be looking at implementing domain-driven design within our Flutter apps. For this series, we'll look at TDD within the problem space of a library. And so we'll create a simple mobile catalog of books, in a sense a virtual library. Here we have a diagram showing the architecture of our application and also some of the concepts found in domain-driven design. Almost, if not every domain-driven design application is mainly made up of 3 layers, the layered architectural approach. And those layers are the domain, the application or the API, and also your infrastructure layer. The domain layer is that layer that represents concepts and ideas from within the problem space itself. This is where we map our objects to represent actual entities within the problem space itself. So for example, since we're looking at a library, we'll see things like books, for example, which is an entity. So within the domain itself, there are certain tool set that we use. And the most basic building block for domain-driven design are what are called value objects within the domain itself, or the domain layer. Now, value objects are objects that the value is of importance. The value is of importance, and in a sense they represent attributes of an entity. Value objects encapsulate values, and so they have within them also a validation for certain values. So in the simplest sense, for example, inside of our books, our book entity, instead of having, say for example, string author where you have first name, last name, you'd create a value object which encapsulates the author's name or all the data about a particular author. And within that object itself, you'll have different validation rules that governs this value object. For example, the name should not be null, or the name should not be blank, that kind of thing. So for our library application, we'll have 5 value objects. We'll have the ISBN, the author, the name, the published date, and also an identity. And the value objects oftentimes relate to entities. Now, entities are those objects where the identity is of importance, and they oftentimes represent a single row within the database, and the state is persisted, or the state is continued throughout the life cycle of the application. So we have a book entity that has value objects, and then we have a bookshelf entity that has books. Now, also within the domain must be a pure layer, totally independent of frameworks and other third-party implementations. We'll also have, within the domain itself, we'll have repositories and we'll have factories that, and these factories and repositories are interfaces, are contracts. The domain layer itself does not implement these contracts, but they are implemented rather in the infrastructure layer. So the domain layer does not depend on any other layer, but the other layers depends on the domain layer. So we have our application layer, which is in a sense a thin layer that orchestrates the different actions performed by the user throughout the application. So this is where you'll have like things like your use cases, right? And in our case, we'll have a use case contract. We have a add book use case, just for example, and we'll have inputs to that use case and outputs from that use case. And then the third layer now is the infrastructure layer, where most of the implementation details lie. So now here you'll have your data sources, and you'll have your repository implementations, and also your factory implementations. And on top of all of that, then you would have your presentation layer with your view model, your views, and that sort of thing. So in a nutshell, this is the overview of our application. And so now we'll go into Visual Studio Code, and we'll, for this particular video, we'll only be implementing the domain layer. So here we are inside Visual Studio Code. And before we start, I just want to show you guys a few dependencies or packages that we'll be using. We'll be using the UUID package for creating unique identifiers. We'll using the INTL package for date formats, and also the Dart package or Darts package to return some functional objects. So since I'll be taking a test-driven approach, I will start with a test. And so I'll structure the test just as how you would normally structure your production code. So since we are dealing with the domain, I'll first start with the domain layer. And within the domain layer, I'll start with value objects. The first value object that I'll look at is title. Title test .dart. So normally when I am writing tests, I normally test for the error cases first, the failure cases. So I want to write a test to validate that an error is thrown or an error message is returned whenever an invalid input is given when creating the title value object. So I'm going to create a group of tests. Title. Within the body itself, going to create a test, and the description should return failure when value is empty. So first I'll arrange title. I'm going to create a title, pass it blank. So in this case, I should expect title to be of type failure. So Dart has a package, a type matcher package that I'll import matcher as matcher. So I expect matcher type matcher. I expect the type to be failure. Right. So this is my test, but currently none of these objects exist, these classes exist, so I'll create them here before I move them to the production code. So I'll create my class title, and within the title I'll have string value, right? And then the title will accept that value. Now, value objects are immutable, so we'll always be creating a new instance whenever the value changes. So I'll make this final, and also there should be some level of equality, so that if I have two objects, two title objects with the same value, then they should be equal. And you could implement object equality here if you want by overriding the hash code and the equal operator, but that would give you a lot of boilerplate code. So I'll use Dart has a package equatable, so I'll use that equatable package. So I'll say extends equatable. And then I'll return here the value. Now this title object now is equatable. I'll also implement my failure class. I'll give it a message. Right, and there we go. So if we run this test, it should fail. since we are not applying any validation logics as yet. So there is our failing test. We expected failure, but we received title. So we'll now apply some validation logics so that whenever the title is blank or null, then we'll return a failure. But in order to do this, we'll be using a special type, a special Dart type from the darts package, which is either, where you can return either failure or the actual result. So in this case, we can return either failure or return the created title. So what I'll do is that I'll make this a private constructor, and then instead of creating the title through the constructor, I'll create a static method which returns either failure or title. Create, which accepts a string value. Import. And so if the value is empty, or if the value is null, then I'll return a failure. In the left side of the either object, I'll return a failure. Title cannot be empty or null. Else I'll return the actual title in the right side of the either. So now instead of the constructor, I'll call the static method create to create a title. So if I run this test again, we still have a failing test, and that is because the object that is being returned is either. So we need to strip or get the failure or the title, the right side or the left side, from the either. So you do that using the fold command, the fold function rather. In the left side we'll have an error or a failure, so we'll return that, and in the right side we'll have the actual title. So now if we run the test again, that should pass. So now we have a passing test. So the failure is being returned. We are getting a failure whenever we create a title with a blank value. So this is the bad path, or the sad path, or the failing path. Now for the positive, which I'll write a test now where it actually creates a title when a valid value is inputted. So should create title when value is not empty. Again, we'll arrange our test. Title dot create, say title of the book, Programming 101. Then we'll say dot get or else. This is another method from the either class, which is to get the correct value or else return something. So in this case I would say else return null. So in this case, get the correct value, which is the right side, which would be the title, or if the title is not present, then return null. But I expect the title to be present. So assert expect title dot value to be equal to Programming 101. If you run this test, there we have a passing test. Run again, and there we have it passing. So what I'll do now is that I'll copy these classes into the actual production code and then test it again. So I'll go here, I'll create my domain. Within the domain, I'll create value objects. Then I'll create my title class. Copy, paste here. Field object, copy, paste here. Go back to my test to ensure it is working correctly still. I'll run the group of tests again. And there we have it, our test working correctly. So now we'll write tests for the other value objects, and we'll create them as we go along. Now the next value object that we'll be looking at is ISBN. So ISBN test dart. Taking the same approach of failure case first, I'll write a test. Should return failure when invalid ISBN. Right? So I'll save ISBN equal ISBN dot create, and I'll enter some random numbers. And just like the title, I expect ISBN to be of type failure. I'll import type matcher. Failure. Now I'll go to the production code and I'll create the ISBN object. And again, since it's immutable, since it's rather should be equatable, I'll extend equatable. Just like the title, I'll give it a private constructor. Then I'll give it that static create method. Which returns either failure or ISBN. So there we have our ISBN object or value object. So if I run this test, it should fail, right? So it's expecting failure, but get an instance of null. So back to our ISBN class value object. We'll create a method, a private method is valid, that will use, so we'll accept the value and we'll use regular expression to determine if it's a valid ISBN or an invalid ISBN. So I'm just gonna copy and paste the regular expression for this. So there we have a long regular expression, and you can find it online. I'll create a regex. And I'll return has match. Now this will return either true or false if there is a match. So back to our create method, I say if not is valid, then I'll return a failure. Now we see we have an error where is valid is concerned, because it's been accessed from a static member. So we'll just make this static as well, and so if is valid value, then we'll return a failure, else we'll return ISBN. So there we have. Now let's go back to our test. Let's run the test again. Let's fold. Let's run again. Seem to be valid. Let's try again. So our test keeps on failing because this should be false. So if it is not valid, then return the field. Let's go back to our test, run again. Now the test is passing. Alright, so let's move on to the next test. Test valid 1. So I'm now testing for ISBN 10, then I'll test for ISBN 13 rather. So I have a ISBN 10 string that I copied, and now I expect that ISBN get or else null, that value should equal to str. Let's run the test. Test is passing. So I'll do the same thing for ISBN 13. So this test is for ISBN 13. Again, I'll copy an ISBN 13 string. Now I'll run the test. Test passes. So now we have our test for our ISBN. So I'll quickly create the other 3 value objects, and then we'll move on to entities. So I've completed the other value objects. So I have the author, I have the identity, and also the published date, which I use the date format from the Untitled Dart package to parse the date to see if it is in the correct format. I have also the tests here, where I'll expect a failure for incorrect format, and also I expect a publish date for the correct format. So the test basically follow the same structure all the way through. So now that we have completed our value objects, we can now move on to our entities. So I'll create a folder, entities, and inside our test, the main, I'll create entities. So the first entity I'll create is that book entity. Class book. This book will have an identity. We'll also have a shelf ID to tell which shelf this book is on. Also have a title, author, publish date. So there we have our book entity. Now there isn't any particular business rule or business logic, domain logic, that is attached to this book. So you can say in a sense that this is an anemic domain model, and you can do further research on that because there are arguments for anemic domain model and there are arguments against it. But in this particular case, there is any business logic that is associated with a book based on the application that we are building. So for now, this is our book entity, and so we'll now create our bookshelf entity. But I'll start with a test because the bookshelf entity will have business rules associated with it. So inside the test for our bookshelf, we'll create a bookshelf, which is the system on the test. Create a setup. So that we instantiate our bookshelf here, and it will have an ID or an identity. And we'll have a group of tests for this particular bookshelf. And the first test, again, the sad path or the failure condition, is that for the business rule is that any one bookshelf can only hold 10 books. So that's the business rule. The bookshelf cannot exceed 10 books. And so bookshelf, for the test, bookshelf, whenever we add a book, it should throw an exception, in this case a domain exception, when the bookshelf exceeds its capacity. So that's the business rule that we are working with. So for this test, I'm gonna generate a list of books, say 11 books. book. So I am generating 11 books from the book entity. And what I expect that whenever I call the add book method on the bookshelf to add a new book, or in this case just to add these books, or rather add a new book. So let me put it at 10. So it's at its maximum capacity, and I am trying to add a new book now. Then what I expect is that it should throw a type domain exception. So I'm going to use time matcher again. Domain exception. So that's what I am expecting. So let us now create our bookshelf. So inside of entity, we'll create our bookshelf. So here we have our bookshelf entity, which say the maximum capacity is 10. We have an identity, and also we have a list of books. So we have books, book, we have our bookshelf constructor, say ID, and this is required. Right, and then here we'll inside the constructor will instantiate that list to an empty list whenever we create a new book. So then the business rule is this method add book now implements the business rule and validates it whenever we add a book. So now whenever we add a new book, we first check if the length, if we have reached the maximum capacity, and if so, then we throw a domain exception, right? Book shelf has reached maximum capacity, right? Else should pass in the book. Else this book, which can be added to the shelf, we'll set the shelf ID on that book, and then we'll add it to the list of books on this shelf. Right. I'll create a getter method to get the list of books. So there we go. Alright, so inside of our domain, let us create our domain exception. Domain exception implements exception. Message, then this message. Alright, so here is our domain exception. We import it here. Then back to our test. Now we can import our bookshelf, import domain exception, and also matcher. Right. We don't need this since we add in a single book. So if I should run this test now, as we can see, the test is failing because we are now just adding one book without the shelf first reaching its maximum capacity. So what I'll do first is I'll add 10 books. So I'll add 10 books to the shelf before I add the 11th book. So now I've added 10 books before so that it reaches its maximum capacity, and now I add the 11th book, and so I expect a domain exception. So this is the test for the failure condition. Now I'll do the test for the success condition. Test add book should add book to shelf. Create a book, a new book. Then I'll add that book to the shelf. Now I expect that books, the number of books on the shelf should be 1, since I've added only a single book and there are no other books on the shelf. Good. So now we have created our book entity. We have applied or implemented the business logic, and we have successfully tested the business logics. So now we have implemented our entities and our value objects inside the domain layer. So now we'll add the contracts for the repositories and the factories. iBook shelf repository dart abstract class iBook shelf repository. And inside here we'll have three methods. We'll have an add method to add a bookshelf. We'll have a update for now. And we'll have a find, which takes in the ID of the bookshelf. So that is the contract for our bookshelf repository. Next we'll create our book repository. So here we have our iBook repository, and we have 5 methods: and add, update, delete, find, and find all. So those are the 2 repository contracts that we're working with for now. So now we'll create our factories, which is to create our entities. So entity factory. And inside our entity factory, we'll have 2 methods: to create a new book, given a title and author, ISBN, a published date, and also to create a new bookshelf. So these are the 4 domain-driven concepts that relates to the domain layer that we have implemented for this particular application. I'll push the code to GitHub so that you can download it. So as in the next tutorial, we'll be moving on to the application layer and to see how it is implemented. So thank you guys for watching, and remember to like the video and subscribe. Thank you very much.